after that we are going to go to the load module. Okay, so in the load module we have different options here. So the first thing we are going to do is to apply the gravitational load, and then in the boundary condition we will be applying different boundary condition for our model, and then we will be defining the free field stresses as well. So starting with the gravitational load, you can go to create a load from here. Okay, so now we are applying the gravitational load in the G step, and here you can see the gravitational load. Continue. Okay, so now you are going to select the overall model. Done. And now we are going to apply the gravitational loads in terms of G. So we are going to select the negative 9.81 and then press OK. So now you see the arrows are showing that the gravitational load has been applied to our model. Okay, and now we can see our gravitational loads here in the load manager. So we have applied that one. You can rename it by gravity or whatever you would like to call it, but I just keep it as it is. Okay, dismiss. Now we are going to apply the boundary condition. So in boundary condition we have two types of boundary condition we will be applying. We will be applying first the fixed base boundary condition at the bottom. Okay, and then secondly we will be applying acceleration as well at the bottom. So we are going to go to the create one. Okay, the boundary condition will start from the initial one. Category is mechanical, and then first we select the displacement and rotational control. So for that we are going to select the, so Abaqus is telling me that select the region where you want to apply this boundary condition. So we are going to select the bottom and done. And here you can see I want to fix it. In order to fix it, I will select all the U1, U2 and U3. Press OK, and now you can see we have fixed our base. And after this we will be applying acceleration. So we are going to go to create boundary condition again, but this time we will apply acceleration in the earthquake step. Okay, and so we are applying acceleration at the base. So we select acceleration, angular acceleration. Okay, and then press continue. Again we select the region. Okay, and done. And here we can check this one, and we will also apply acceleration in terms of the gravitational acceleration G, and here we will select the amplitude which we already created previously as Chuyotsu, and then press OK. So as you can see, these arrows shows you that the acceleration, horizontal acceleration, is applied at the base. But we are going to change one thing in the boundary condition manager. So first we created the boundary condition of fixed base, or we can change the name, edit, and you can change the name of this one as base, fixed base. Okay, and this one you can rename as earthquake, your EQ. Okay, so now in the earthquake step we are going to allow the base to move. So for that purpose we are going to double click on this one. We are going to remove constraint from the horizontal one, because we want to we would like the base to move when the earthquake is applied at the base. So we are going to click on OK. So as you can see, this change from propagated to modified. Now this is complete. All right. So we applied the boundary condition as well. Now we create the predefined field. So you can click on the predefined field here, and in here you will select the initial step, which is already selected, and then the category is mechanical, and here we select the geostatic stresses. Okay, so now because it's asking us which region we want to apply these stresses, so we will apply stresses only in the soil part. So what I'm going to do is to remove building for now. Okay, and then I'm going to select the soil region, and done. Now we will apply the geostatic stresses at 2 points, first coordinate and the second coordinate. So initial coordinate, we will select the top coordinate and the bottom coordinate. So as you know that the geostatic stresses at the surface is 0, so the stress magnitude at point 1 will be 0 here, and the stress coordinate and stress vertical coordinate is 0, because this is the 0, 0 central region of the model, so it will be 0. And then the second stress magnitude will be the rho into g into h. So we have the density of 1550 into 9.81 into 36. So we have this value of 5437398. So minus, because it will be in downward direction, 547,398, and the vertical coordinate will be minus 36. Okay, and the little coefficient we will use here is 0.3, and that's it. As you can see, the model changes, which means the geostatic stresses has been applied to our model. Alright, so now the load module has been completed, and now we are going to go to the mesh module. Okay. Okay, so in order to mesh our building part, we are going to use these tools. As you can see, we have the seed and seed edges. So first we are going to select the seed part. Okay, now it is telling me that we have this global seed. So the global seed means the overall nodes of the overall part you selected. So Abaqus is giving me the approximate global size by default is 0.2, so which means that the thickness of the roof was 0.6, so this is dividing it into the three spaces. So I think I'm gonna keep it as a default and apply, and then OK. After applying the seeds, you can select the mesh part, and then you select then OK, and right, so we can see that the building part has been meshed. Now we are going to go to the second part, the soil one. So if I click on the seed one, yeah, the global size, approximate size as per the overall geometry, and the partition we already made, the approximate global size Abaqus is suggesting me by default is 1, so I'm gonna keep it 1. You can change it to different seeds. For example, if I apply 1, so it gonna mesh is like this. If I apply 0.5, make the smaller mesh and apply, so the mesh seed changes. So I'm gonna keep it 1 and apply, and OK, and go to mesh, and then OK. So here we are, we have the meshing done for the soil part as well. Now we are going to select the mesh element type, so it depends on the analysis you want. So in our case, as I'm using the 2D model of the soil, so it is recommended that the element type of the mesh has been used is a plane strain model. So now, as you can see, is the plane stress, so I'm going to select the plane strain, linear reduce integration. So you see the element type is CPE 4R. So this is the element type which we usually use when we model the soil in 2D. Okay, so we are going to select OK and then press OK. Similarly, we will be doing this for the building as well. Okay, from plane stress to plane strain. Alright, click. So now if you go to the assembly, here we have the meshing of both building and the soil part. So now we are done with all the module, and now we are left with the last one is to create a job. So I'm gonna name it job 1, or you can change it to whatever you want. So we're gonna keep it by job 1. Okay, and continue. Here, as we can also press the full analysis, okay, and press OK. And in the job manager, you can see that we have created a job, and the only thing we are going to need it is to submit the job. So so after saving this, we are going to click on the submit, and now it is running. You can monitor the job by clicking on monitor. So as you can see, it is running now. I think it will take a little bit of time, so after it is done, I will be discussing the further step with you. Alright, so now our model has been completed. The only thing left is to check the results. So how we're going to do that is go to the results. Here you can see we are in the visualization module now, and we can check the results. Acceleration and then play. Alright, so here you can see the acceleration, and then you can change it to the displacement and whatever you want to see, the stresses and the velocity. So these are the different ways to check your results. And similarly, you can get the results by clicking on the XY data. Alright, so if you want to get the data of specific node, for example, so I'm going to go to the ODB field output, and here in the unique nodal, I want to check the response of the specific nodes, and let's say I want to check the response of the top of the roof. So I'm going to check the horizontal acceleration. Okay, and then in the node I'm going to select the top surface node. Please click on the node, done, and then you can check and plot the results. So here you can see is the acceleration time history of our roof, and then here in XY data drop down list you can get the data by clicking and editing. So this is the time and acceleration on the Y column. So this is how you can create your model, set up the steps and different loadings and conditions on it, and then after running the model you can play around with the results. So this was all that we have here in this today's tutorial. If you have any questions, you can comment and we'll be able to answer those questions. Thank you so much.